welcome again to this channel. This is G Solutions. Today we will understand what is a critical path method, a technique which is so what is a critical path method? Actually, this is a scheduling techniques in construction, and it is very popular because of its simplicity and effectiveness. This was also developed by DuPont company, and this company applied it first in chemical industry projects. These CPM techniques list all the project activities, and also it includes information about the duration of each activity, how long will it take, and how it relates to the completion of the other activities. Then it is crucial in this method to determine the critical activities that requires attention to be able for us that the project can be completed on the right time or on time. And you will see that it is represented by a graphical view. Your project will be in a representation of a graphical view, and it also calculates on that graphical view. You can calculate how much time and resources will the activity be completed. So the basics of this CPM, the first thing that we should know are the components of the network. To represent it in a graphical view, we have these two components, the activity and the events. The activity represents an action and consumption of time, money, and energy, or the resources. You need this one, the action and the resources, to be able to complete the portion of a project. In our graphical view, it is represented by an arrow. In the rectangular box, you will see that arrow is noted by letter A, which is called as an activity. And for the event also, or a node, it has a beginning and an end. It is represented by a circle in your rectangular box. So the first one is, here we use this letter I, which is the tail event or the beginning of the activity, and the head event or which is represented by letter J. This is the end of an event. So those are the components of the critical path method network. Now, there is also an instance where there are one or more activities before an event will start, and you call this as a merge event, as shown here in the rectangular box and letter A. So you have here three arrows. It means that there are three activities before the event will start. So we call this as merge event. And also burst event, as shown in the figure, our letter B. After the event, there are three arrows that comes out. So from that event, it produces 3 activities. So we call this as burst event. And you should know also the preceding and succeeding activities. What are those? The preceding activities are the activities performed before the other activities. For instance, in our instance here, in our rectangular box, the letter A precedes C and letter B precedes D. So these are the preceding activities, and the succeeding activities are the activities performed after a given event. So C succeeds A and D succeeds B. So this is how we call it in this CPM techniques, the preceding and succeeding activities. We also introduce a dummy activity. This dummy activity is an imaginary activity which does not consume any resource and time. It is simply used to represent a connection between events in order to maintain logic in the network. And you will notice that in your graphical view, it is represented by a dotted line, which was shown also here. Here is the dummy activity, this arrow. Now we have to avoid some errors in constructing our network in our graphical view representation. The first one is 2 activities starting from tail event must not have the same end event. In this rectangular box, this figure is incorrect because it started on the same event 1 and it ends in 2. So this same activity started from a single event and it ends to another single event. It should not be like that. In this case, you have to introduce a dummy. So the correct representation is this one. So it started from event 1 and the activity goes to 2, and then you introduce a dummy to 3, and then another arrow from 1 to 3, which is the event, which is the activity from event 1. Okay, and also a looping error should not be formed in a network. When you say loop, it means it is where you started, it ends there. So that is incorrect. That is a looping error. In this case, we have here a figure, event from event 1 and activity, and goes to event 2, and then activity goes to event 3, and then from event 3 activity, and it ends up to event 1 again. So looping, this is a looping error which should be avoided in our graphical view representation. Another thing is, in a network there should be only one start event and one ending event as shown below. So again, let us note that the start should be one event only and it should end on one event only. And the direction of the arrow should flow from left to right. It should flow from left to right to avoid mixing of direction as shown. So if it doesn't follow that the direction the direction flow is not from left to right, it will be going back again to the looping error. Okay, and take note of the rules in constructing a network. So no single activity can be represented more than once in a network. And always remember that the length of an arrow has no significance. It just gives us the direction. Number 2, the event numbered 1 is the start, and the event with highest number is the end. So before an activity can be undertaken, all activities preceding it must be completed. So it should follow a logical sequence or interrelationship between activities. And number 3, in assigning numbers to events, there should not be any duplication. If it was already used, if the assigned number is already used in an event, it should not be any more used in any event or in the graphical view representation. Number 4, dummy activities must be used only if it is necessary. So to make the network logical and to reduce the complexity. A network should have only one start event and one end event. That's for number 5. So these are the rules in constructing network. So some conventions of network diagram are shown here. For letter A, as you see that activity B can be performed only if the activity A is true. And so also with activity C, it can be performed only after activity B is true. So those are some of the convention we should know. And for the letter B, you know that activity B and C can start only after the completion of activity A. For letter C, here we can see here that activity C will start only after the completion of activity A and B. And for letter D, you can start only activity C here after the completion of activity A and B, which was introduced by dummy activity here. And activity D can start only after activity B. Okay. In the Fulkerson's rule, these are the procedure for numbering the events. We follow the Fulkerson's rule. Number 1 for the step 1 is you start always with number 1. So that will be the initial event. Step 2, so from event 1, strike off all outgoing activities. And this would have made one or more events as initial events. So you can also number that event as the next higher number, which is 2. And then for the step 3, you repeat step 2 for event 2, event 3, event 4, 5, till the end event. So the end event must have the highest number. So that is the Fulkerson's rule. Now let us go to the example. It says here, draw a network for a house construction project. The sequence of activities with their predecessors are given in the table below. So you have here a table in which these are the name of the activity from A to F, and also the event was stated in each activity. For instance, for letter A, you have event 1 and 2, and the description of activity, which are this one. Letter A is the preparation of the house plan. Letter B is the construction of the house, where you construct the house. Letter C is fixing the door or windows and so on and so forth. So these are the description of activity, and also the predecessor are given here. For letter A, there is no predecessor. For the letter B, or the activity B, which is the construct of the house, the predecessor is A. It means that before you can have activity B, activity A should be done first. So the preparation of the house plan should be done first before the construction of the house. And the time duration also is stated here. So activity B has 58 days duration. Now for letter C, here, which is the fixing of the door or windows, the predecessor is B. So it means that after the construction of the house, letter C, or the activity C, can be started, and the duration of this activity is 2 days, so and so on and so forth. So we will construct a graphical view representation of this construction project. So here it is for activity A, which is the preparation of the house. It started at event 1 here, and it ended at event 2. So we write also the duration, which is 4 days. There is no predecessor for activity A. Okay, and then for activity B, which is the construction of the house, which also have a time duration of 58 days. It is represented by this one. Since that activity B can be started also only if the activity A is true. So here is the representation. So B is now placed here, and then the event are from event 2 to 3, and I write also 58 days. Next is the C and D activity. So C activity can be started only if B is true, so you place it here, and also D can be started also only if B is true. So after the completion of B, C and D can be placed, and we have here also the starting and finishing event of each activity, which are for C is 3 and 4, and for D is 3 and 5, and each has a 2 days duration. And for E and F, the same thing, the same concept. So E here can be started only after C is true, and F can be started only after the completion of activity D. So again, the starting event is 4 and 6, and 5 and 6 for activity F, and we also place here the time duration. So it started from event 1 and it end up to event 6. So this is the graphical view representation of that problem. And then another example, it says here, consider the problem, or the project given in the table below, and construct a network diagram. So we have here a limited given or limited data, since that the events are not stated here, only the activity and the predecessor and the description of the activity. For activity A, that will be the purchase of the land, and it has no predecessor. Letter B, in the preparation of building plan, it has no predecessor. And C is the leveling or cleaning of the land, and the predecessor is A. A is the purchase of the land. So before you can have the land leveled and cleaned, you must purchase it first. Okay? And for the registration and approval, which is the activity D, A and B should be complied first. So A is the purchase of the land and B is the preparation of the building plan, and so on and so forth. So yeah, so this is the probable graphical view. The first one is here. So you know that if you are going to make it like this one, which is here we have the purchase of the land and B is the preparation of building plan, and it has no predecessor, you can write it like this one. It has no predecessor, and this is the beginning event and it ends here. But you will remember that we are violating the rules in graphical view representation, because according to our rule, the event should not begin and end on the same, the activity, two activities here is beginning and ending on the same event. It should not be. So that is against our rules in setting up a graphical view representation of our CPM. So this is incorrect. And the other possibility is like this one. So you have here two separate starting events for A and B, and it ends up in common events. The activity A and B ends up in common events, and it started in different event. But if you will go to the given matrix, it is true that A and B has no predecessor, and but you can see here that activity C, the only activity that precedes activity C in our given matrix is A. So in this case, activity C, it will be in this graphical view representation, the activity C will have two activity that precedes C activity, that will be A and B. So it is incorrect. It is incorrectly not stated here in our matrix, in our given matrix of the problem. So this presentation is also incorrect. The correct one is this one. You introduce a dummy. So for the purchase of the land, there is no predecessor, letter A. In the preparation of building plan, there is no predecessor, so it started on the same event. And then you introduce here a dummy. So for A, to be able for us to comply with this given matrix, which let activity C can only have a predecessor A. So you introduce a dummy here. So in this case, C activity is preceded by A. So this is now correct. And also our activity D have two activities, which is A and B. So you will see it here. B and A will be taken by this dummy arrow or dummy activity, and so on and so forth. So this is now the correct graphical view representation of this problem. So this is all. Thank you so much for watching this video. Don't forget to subscribe and like and comment. This is G Solutions. To God be the glory.